Welcome to the presentation of House Abstraction Layer, also known as HAL. It's the Internet of Things Management System. The presentation is just going to go over a high overview of basically what House Abstraction Layer is as a project for an IoT management system, the fact that we're able to control a Philips Hue, a Stel Pro Thermostat, as well as some GPIO pins on the Raspberry Pi for future expansion of the management platform. The team members as it stands are myself, Josh, Scott, as well as Simrat. So the problem is the advancement of technology has led to a vast market of IoT devices. The issue with that is each device has its own interface, which can lead to you having 5 or so different interfaces you have to access just to get some lights or some temperature to match up with what you want in your house. So what we've proposed is we're going to make it easier for the user to control these devices. We're going to use third-party applications APIs, but we're all going to have them under our management platform so that we can guarantee some more security and privacy of the data by keeping it all local within the house's system as well. That's why we've proposed the new management system to control these devices as well as keep track of records and security. With the solution, HAL management system is going to create a single interface for the devices to be managed from, which includes, as we've said, the Philips Hue, the Stel Pro Thermostat, and the GPIO pins are all easily controlled and configured. It also fulfills the need of security and privacy of the data by keeping it all local on the network, but having set up so that there is a firewall or a VPN to access. The data of the house doesn't leave the network, so keeping it more secure and private. Some of the features that we've implemented are, once again, control of the GPIO pins. The pins are located on the Raspberry Pi and have been initiated to have a simple turn on and off from the interface. We can also set schedules to the pins. The purpose of this is so that the pins can further be linked to either light switches or electrical outlets such as dimmers or other things so that we can control the flow of electricity with the GPIO pins. We also have it as a brief screenshot here of the web interface for the GPIO pins. And then we also have the feature control Philips Hue. So we are able to control the Philips Hue bridge, which means we have access to the lights, and from there we can change brightness as well as whether or not the light bulbs are on, and set schedules for the Philips Hue to be turned on or off as a wake-up or kind of a nighttime setting thing. Here we have another screenshot of the interface very quickly. And then, of course, we have one of our other features of HAL is the thermostat control. So through this, we can turn the thermostat directly on or off through the interface, as well as, once again, set schedules that we can have the heat turn automatically so that when someone arrives home, that the house is nice and warm. We can also create a set heating point so that at any time the furnace will turn on, and that heating point will always be kept at constant and heated. Then we also use a feature of the Zigbee network to create this. The reason we're using the Zigbee networking protocols is because of the low power consumption needed, as well as the fact that it creates its own network and grows as the devices are connected. So the more devices you get, the larger your network will have range over. It also allows huge amounts of connections for large scalability. I'm going to pass off hardware components to Simrat now.
Yep, I will going over the hardware and the software components of the HAL. So the first component it consists of is the server hardware. We have used the server to host our virtualized environment for the honeypot creation. The honeypot we have it just as an added security feature. The server also holds the main pfSense router, which acts as the main VPN connection for it. It also holds the 2016 server, which has the Active Directory role installed so as to control the log server as well as the database server. The Raspberry Pi connects to this server hardware using the VPN connection. The another hardware component is the Raspberry Pi. This Raspberry Pi is used to hold the web server configuration of the system. This Raspberry Pi acts as a MySQL server for storing the username and passwords for the login users. This acts as an intermediate controlling device which controls the IoT devices further. The Raspberry Pi also acts as a GPIO pins which can be further expanded based on the future needs. The Philips bridge and the Philips Hue are a part of our project. The Philips bridge controls the Philips Hue. The Philips bridge is controlled with the help of the Raspberry Pi using the web interface. The Stel Pro Thermostat. This is the main thermostat installed in the house. This is controlled by our system using the Zigbee protocol. The USB-C to CC2531 packet sniffer. This acts as a Zigbee network router for the Zigbee network. It detects the packets as well as transmits the Zigbee packets to control the thermostat on our system. The software components of this HAL system is we have the pfSense, which acts as an open source firewall and router. This is installed as a virtual machine on our dedicated server. This provides extra security by acting as a firewall as well as the intrusion detection system. This pfSense consists of the SNOT module which acts as an intrusion detection system. The Windows server. This server holds our Active Directory and also acts as a DHCP and DNS server for our system. This Active Directory and the server we need it to control our log server as well as the database server. The SNOT module. This acts as an IDS system which stands for intrusion detection system. This module is able to scan the network for any unwanted traffic. This SNOT can be used to block or log the unauthorized traffic over the network. We use this also to block the denial of service attacks on our system. The mosquito broker. This is the message broker for the Zigbee network which is used by HAL and the end devices. This operates on various MQTT versions, uses JSON as an object format. This creates more secure client sessions with the Zigbee network. So for the server services, I hand over to Scott.
So for server services, we run 5 server services. We run a DHCP server, DNS server, web server, MySQL database, and then we also run Active Directory. So the DHCP server service, that stands for Dynamic Host Configuration Protocol, and we utilize that to give all of our devices on our networks addresses. So for us, we have a honeypot, and we also have the normal network that our devices for our actual HAL sit on, and so we have to assign different addresses to those and for different subnets. So each of those have their own subnet, and each of them looks similar as networks, so it means that people will think that the network is the same, and it goes into our intrusion detection and our security features. So with the help of this, a server can assign these IP addresses automatically, and then you can also have them statically assigned. So with this as well, we use DNS. So with DNS, our DNS server helps resolve hostname queries on the network for each device. So we do this in order to resolve our web server and allow access to our web server and you to be able to control and access our web server from anywhere. So we run some lookup zones that have naming conventions for those devices, and it's required for the resolution of new devices and for the communication with the VPN so that the website can work properly and we can control the thermostat and the lights remotely. The web server. So the web server is the service that fulfills all of the client requests for the HTTP protocol. So this is where our website is hosted, and this is what controls our devices, like the lights and the thermostat, through the web server. It all goes through the web server. So it consists of one website. It's currently, and that's just our HAL website. And we use Apache for our web server. So our MySQL database is being run on a different server, but it communicates directly with the web server. So a database, it's an organized collection of data, and we use that to store all of the user info for our website. So the user credentials are all stored on the SQL database, and then that communicates with the web server to make sure that we aren't allowing intruders to gain access and control our thermostat and our lights when they aren't supposed to. This also stores new users and login attempts and all that stuff. So Active Directory, so this allows us to communicate and connect all of our devices together and make sure that they're added to the same network. And it allows for differing levels of security and stuff based on users and groups, and allows for easy access of our easy management of our domain. The networking components. So we have some networking components on our network. Because of the current situation with COVID, we've had to add some network complexities that we didn't really want. So first we have our normal ISP router, and this ISP router we have to use, we've had to modify settings on it to allow Josh's house and Scott's house, the two different sites that we use in our project, to communicate together. So then these communicate all together with devices that are on the physical server. The physical server holds the virtual machines for the database server, the pfSense, the DNS server, and this also has like the Active Directory and stuff running on the DNS server there. And then it also holds all of the VMs for the honeypot. And so we basically have created two identical networks running in VMware that use LAN segments, allowing all of this to work. Then the pfSense virtual router here, that is just a virtual machine running on the physical server, and that allows for the OpenVPN to work, and allows for connection and between Josh's house and Scott's house. So the OpenVPN is what's represented here with the cloud between Scott's and Josh's house. And this gives the Raspberry Pi an IP address that is on the LAN side of the pfSense, not on the WAN side. So then that allows the Raspberry Pi to be able to communicate with all of these other devices on the network, like the database server and the DNS server and the Active Directory and stuff. Then the database server here, that's what's running MySQL and communicating with the Apache server that is running on the Raspberry Pi. And then we have the DNS server, and the DNS server grants name resolution for everything. So, next slide, we just have kind of a list of our networking components and where it's all kind of contained. So, security features. I touched on some of these already, but our security features, the HAL uses a secure logon web interface that is maintained by the MySQL database. So the usernames and passwords are all stored in the SQL database, and then they're stored encrypted using a 256-bit hash algorithm. So this hash algorithm is built in as a PHP function in the web interface. And then the secret passphrase that you've created for your user is required to gain access to the website. So not anybody can control the thermostat. So the pfSense has a built-in firewall and snort module, and the firewall, we've used it to block any unwanted traffic, so things like DOS attacks or unwanted access to the SSH that we use to control some of the other things and stuff like that. And then snort is an intrusion detection system. So the snort and the firewall kind of work hand in hand to firewall can block stuff, and the snort can also block stuff. But the snort main purpose is to monitor incoming traffic. So for the snort, for one example, we use it to monitor the incoming traffic of the VPN, so that we know where the VPN connections are coming from, and then we can monitor them. So the VPN, we use the VPN to grant devices outside of the network internal access to the HAL network through a secure tunnel. And then local machine files permissions, the running the scripts are put into a group, or the users that run the scripts are put into a group that only accesses those permissions and those files, so that you can't access other files on the machine. So Simrat will talk about a little demonstration about the HAL now.
Yep, thank you, Scott. I'll just take you to the HAL demonstration site here. As you can see, this is our main web interface for the HAL management system. So this is the first page of the user interface. From here you can log in if you're a previous user, or you can click here to add the new user. In order to add the new user, you have to enter the secret passphrase, which is set by default. If this passphrase is correct, we can just enter the new user details. So if we just enter the new user details here, it says the user has been added, so we can just log in using that user. And if we just log in from that user here, as you know, this password is stored on the MySQL database, so this is in 256 hash algorithm, which makes it more secure. Further, to increase the security, the login information is also sent to a remote server, which takes count of all the correct login or invalid login attempts into the system. So in case we have any invalid attempt, that is also recorded on the log server. Once we log in using the correct user credentials, we'll get to the main HAL interface, which is able to control the devices. So for this, I'll just hand over to Josh to explain the first two sections of the web interface.
Alright, as we can see here, we have the original IPO or GPIO interface here, and we can just click and turn them on or off with a neat little graphic. Then we also have scheduling time to turn the lights on and off. Then we move down to the thermostat. Now, to demonstrate our thermostat, we have it right here. And then we also have this light. Now the light will simulate our furnace turning on and off. And to show that we're going to do that, we're just going to turn it on right now. And it's, as you can see, on. So then we also have the ability to see whether or not the furnace will be running or not. And then we can go back to the home page. We can also turn it off, as well as set the heat point, as you can see from down in the section below. And then we also have a point where we can set the status of the furnace filters and have them be changed or not. Scrolling down further, we can see the Philips Hue section, as we can connect to the Philips bridge for a first time kind of configuration. And then we also have how many lights. This is just a simple page to show you how it works. We would enter the subnet, and from there we're able to link our Philips bridge. All right. Excellent. And then we can scroll back down. And once again, we can see that the lights, and we have that light as my office light right now, and we're going to turn it off, leaving me in the darkness. And there you can see it's completely off. We can go back and we can also set the brightness to be a certain or half amount if we want. Now we'll turn the light back on so we can adjust the brightness, and you can see that as well. We're just going to turn the brightness down, and you can see it dim as well. Finally, at the bottom of the page, we have a schedule for the lights so that you can set them on or off, as well as delete schedules. You can create the name, enter the light ID you want used, and then set the time as well as turning them on and off. You can also delete the schedules. Alright, I believe that concludes our demonstration of the web interface. Thank you for joining and watching our presentation.